Good morning, scholars. I am Mrs. Sams. I teach 8th grade math at West Chatham Middle School. Today's lesson, we are going to apply the properties of integer exponents to generate equivalent numerical expressions. The lesson goals for today are to write a product as a power, simplify expressions containing integers, and develop rules for simplifying our expressions. Vocabulary, powers, base, and exponent. In this lesson, the student will be able to, that's you, write and evaluate expressions with positive integer exponents, investigate positive and negative integer bases, define the terms power, base, and exponent, and lastly, develop and use rules for simplifying powers. Exponents and powers. Exactly what is a power? A power is made up of a base and an exponent. An exponent tells you how many times to multiply a base by itself. In our example here, we have 2 raised to the power of 2. 2 is our base. 2 is also our exponent in this example. Let's take a look at another one. We can write a power as a product by writing out the repeated multiplication. 2 raised to the 7th is the same as 2 times 2 times 2 times 2. We can expand it and see it. The power 2 to the 7th can be read as 2 to the 7th power, the 7th power of 2, and 2 raised to the 7th power, not 2 to the 7th, okay? All right, so let's practice. Let's identify the base and the exponent of our examples here. Okay, so in A, what do you think the base is? We would say 4 is a base. What about X? X is a base. And 2 is the exponent. Okay? B, what's the base here? 4 is the base. Nope, that's wrong. X is the base, 2 is the exponent in the first one. In the second one, 4x is the base, and 2 is the exponent. Okay? C, this one looks a little different. Would it be negative 4x? You're absolutely right. Negative 4x is the base, and 2 is the exponent. And what about this last one? It looks a little different, doesn't it? Okay, let's see. Negative is not part of the problem. 4x is your base. 2 is the exponent. Now, why is that the case? The exponent, the digit next to the exponent is your base. The only thing in this particular problem that's being raised to the second power is x. The only thing here is 4x. Everything in the parenthesis is being raised to the second power. C, negative 4x is being raised to the second power. Everything in the parenthesis is being raised to the second power. In D, the negative sign is not inside the parenthesis, therefore it is not being raised to the second power. Okay, let's try to take a look at something else. Here we're going to write each as a product, then we're going to calculate it. 1 is right next to 2, so we have negative 1 times 1. About here, we have negative 1 times 1 times 1. Okay. Here we have negative 1. Here we have 1. Negative 1. Negative 1 times 1 times 1 times 1 equals negative 1. Everything's negative 1. Here we have negative 1 times 1 times 1 times 1 times 1 equals 1. Here we have negative 1 times negative 1 equals 1. Something's different here, huh? But then we have -1 times -1 times -1 equals -1. -1. And -1 is being raised to the fourth power here. Notice it's inside parentheses, so it's -1 times -1 times -1 times -1 equals, what do you think? 1. And here, -1 times -1, get my negative sign, -1 times -1 times -1. Is that 5? 1, 2, 3, 4, 5. Okay. What's our solution here? -1. What do you notice? So we know that this is going to be negative no matter what because the negative sign is not inside parentheses. But what happened down here? Don't these two kind of look like they could be the same? Yeah, the difference is the negative sign is inside the parentheses. So therefore, you're multiplying -1 times -1. And if we remember, a negative times a negative equals a positive. Absolutely. Okay. And notice here, there's only 3. Can we come to a summary? Let's see. Even, odd. So if you have an even number of negatives, your answer will be positive. And if you have an odd number of negatives, the answer will be negative. Absolutely. Okay. Let's evaluate these expressions and see which expressions are equivalent. Okay. -3k. So we know the only thing being raised to the second power in this one is k. Absolutely. Let's expand it and see. If we were to expand this, we have -3 times k times k. And what about here? -3. That should have been raised to the second power. How did you get down there? Okay, times k. Look the same? Okay, and what about here? -3k times 3k. And here we have -3k times -3k. Which expressions are equivalent? You're right, A and B. Okay, good deal. All right, let's move on. We're going to be using properties of exponents to generate equivalent expressions. Here we're going to be looking at our laws of exponents. Exploring products and powers. So when multiplying powers and the bases are the same, we're going to add the exponents and keep the base. Okay, so our directions want us to rewrite each expression by writing each power as a product, and we're going to record the number of times the base was used as a factor. Okay, so here we have 2 times 2 times 2 times 2 times 2 times 2 times 2. How many times is 2 written? 1, 2, 3, 4, 5, 6, 7. So now we've written this as a power. 2 to the 4th times 2 to the 3rd is the same as 2 to the 7th. Let's try B. -3 times -3 times -3 times -3 times -3. 3 is our base, and it's written 1, 2, 3, 4, 5 times. So -3 raised to the third power times -3 raised to the second power is the same thing as -3 to the fifth power. Okay? Now you try C, D, and E, and we'll come back. So pause the video. Okay, so let's see. What do we have here? There's A. Notice there's no exponent here, but we have to include it, don't we? It's part of the expression. So there's only one A here, okay? It's being multiplied by 8 more A's. A times A. Okay, you got to help me count now. 3, 4, 1, 2, 3, 4. I need 4 more. 1, 2, 3, 4. Okay, so A is our base. And what's going to be our power? Have you noticed something? Have you figured out the rule? Does it work? Yeah. Do we have to expand them all? Let's see if we can just do the math in our head. Let's see, we have m to the second, and we have a p, and so that's plus 3 and 2. There is 1 right here. Sometimes you might want to just go ahead and put that 1 there so you don't forget to add it. There we go. And finally, we have m to the 5th power, p to the 3rd power. Good job. All right, last one. We have 9 to the 3rd power. I don't think it's going to change. Okay, 9 to the 3rd power. We have y to the 2nd power plus y to the 5th power, and we have g to the 2nd power. Finally, 9 to the 3rd power, y to the 2 plus 5 equals 7, and g to the 2nd. Good job. This was products and powers. When the bases are the same, we are going to add the exponents and keep the base. All right, exploring powers to a power. When multiplying a power to a power, multiply the exponents and keep the base. The exponential expression 4 squared raised to the 3rd power is a power to power. Notice this is a power, and it's being raised. It can be written as 2 repeated multiplication expressions using the definition of power. So the definition of power, we can expand them out. Okay, so we have 4 squared raised to the 3rd power, 4 squared, 4 squared, 4 squared. So 1, 2, 4 squared raised to the 3rd power becomes 4 squared times 4 squared times 4 squared. Now we're going to square our 4s. That makes sense? Okay, so we end up with a total of 6 factors for 4. So this would be 4 to the 6th power, 4 squared. The rule says when we're doing power to power, we want to do what with our exponents? Multiply them. Okay? Multiply the exponents and keep the base. Our next rule, we want to write each power to a power as repeated multiplication, then write the number of times the factor shows up. So 8 squared is being raised 3 times. 8 to the 2nd power times 8 to the 2nd power times 8 to the 2nd power becomes 8 times 8 times 8 times 8 times 8 times 8. Our base is 8, and it's being multiplied how many times? 1, 2, 3, 4, 5, 6. Oh, so that's 8 to the 6th power. We could have just simply did 2 times 3, huh? Yeah. Okay, but let's do it again. So we have 5 to the 4th, 5 being raised to the 4th power, and then being raised to the 2nd power. So we have 5 to the 4th power times 5 to the 4th power becomes 5 times 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 5. 5 is our base. You got it. 8. It's 4 times 2 is 8. Okay. J to the 3rd is being raised 2 times. J to the 3rd times j to the 3rd is j times j times j. You're working with me, right? J. Okay. So we have j to the 6th power. Now I'm going to let you do that one on your own. Okay. So we should have ended up with 2p to the 6th power. Very good. Okay. Now we want to explore quotients and powers. Quotient, what operation is that? You got it, division. So now we're going to be looking at, well, what do I do with powers when I'm dividing? So I've learned that if I'm multiplying powers, I'm going to add the exponents. If I'm multiplying a power to a power, I'm going to multiply the exponents. Now we're dividing. Let's see. When dividing powers and the bases are the same, subtract the exponents and keep the base. Okay. Let's use the definition we used earlier. Let's expand it and see what we have here. So this says 9 to the 5th power. So 9 is going to be expanded 5 times in the numerator and 2 times in the denominator. Okay? Remember how we can simplify? Let's see. This one cancels and this one cancels. What am I left with? 9 to the 3rd power over 1. Oh, so 9 to the 3rd power. Okay. Let's try one more. 5 times 5 times 5 times 5 times 5. Bases are the same, so we're just expanding them. And here we have 3. 5 times 5 times 5. Okay, this 5 cancels that one. This one cancels that one. And we're left with 5 to the 2nd power over 1. So 5 to the 2nd power. Remember, when you are dividing and the bases are the same, we want to subtract the exponents. Okay, so it's your turn. You're going to do C and D. Doesn't matter that they're variables. Okay, so Z would be 8 minus 6. What's 8 minus 6? Z to the 2nd power, absolutely. Okay, so what's going on here? Is there a rule for this one? No, there isn't. We would just simply divide. If we knew the value of U and the value of X, we would simply follow the order of operation and solve. So there's no special rule for that one. Good for you. You didn't get stuck on that, huh? Okay. You're going to go ahead and do these 4 problems on your own. Okay, let's take a look. Here we should have had 6 to the 5th power. Here we would have had, oh boy, it's going to be negative 9 to the 2nd power. Here we would expand 2 times 2 times 2 and 3 times 3, and we get 8 over 6 and simplify. Okay. Let's take a look here. Oh, this is a doozy here. Okay. Let's go ahead and just simplify this. We have 12 divided by 2 equals 6. We have x, 4 minus 1, and y, 5 minus 3, gives us 6x to the 3rd, y to the 2nd. Oh, that was a good one, huh? Yeah. Okay. Simplify an expression using the quotient rule of powers. Okay. Then we have powers with the same exponent. When multiplying or dividing powers and the bases are different and your exponents are the same, we're going to go ahead and multiply the bases or divide the bases and keep the exponent. Okay? Here we have 12 times 6 is being multiplied by itself 3 times. So let's just go ahead and multiply 12 times 6. 12 times 6 is 12, it's 72. So we have 72. to the third power. Simple enough, okay? You try the next three. Good job. What do we get? Equals 35 to the sixth power. Very good. 1/2 to the third power. And 3 to the second power. Good job, scholars. Now, can you tell me, how does multiplying powers with the same base differ from multiplying powers with the same exponent but different bases? Absolutely. When multiplying powers with the same base, you subtract the exponents. When multiplying powers with different bases but same exponent, perform the operation on the basis and keep the exponent. Outstanding. Okay, here's our closing. Who's correct? Raymond says that 2 to the sixth power equals 12. Randy says that 2 to the sixth power equals 64. Who's correct? Yes, Randy's correct. Where did Raymond go wrong? What do you think Raymond did? Yeah, he did, didn't he? He multiplied 6 times 2. It's a common mistake when we're learning exponents. Okay, let's take a look at the second one. Isabel says that 2 to the second power plus 2 to the third power equals 2 to the fifth power. And Elizabeth says that 2 to the second power plus 2 to the third power does not equal 2 to the fifth power. Who's correct? Absolutely, Elizabeth is correct, isn't she? Because we went over no rule that says what we do when we're adding. If this were the case, you would do 2 times 2 plus 3 times 3 times 3. So Elizabeth is correct. Okay, scholars, thank you for joining me today, learning about exponents, and I'll see you next time.